Now here we see how to use the substitution method for definite integrals. While replacing the existing variable with a new variable, the limits of the integrals must be replaced accordingly. As the final value of definite integral does not depend on the variable used, hence there is no need to resubstitute the old variable. So as we will see later in the properties of definite integrals, first of all, the definite integral does not depend, or the value of the definite integral does not depend on which variable we use inside the integral. So whether we call it as x, y or u, the definite integral's value will not change. So if we contrast this with the process that we do in indefinite integration, whenever we substitute with a new variable, at the end we have to resubstitute back into the old variable or the given variable. But here in definite integrals it is not required. So that is the first point. And the second important point is, when we use the substitution for here definite integrals, it is not that we have to just change the variable, but we have to change the limits of that new variable also. So let us understand this with the help of one example. Now suppose we have to evaluate the integral of sine cube x into cos x between the limits 0 to pi by 2. Right? Now here, as we know, basically we have to first evaluate the indefinite integral of this, because looking at it we can see that it is not very difficult to calculate. So if we put sine x with a new variable, say t, then we can see that the derivative is already present in the integral. So if sine x is t, then differentiating we get cos x dx is equal to dt. Right? So that is the variable replacement part. Now we have to change the limits also. So for that, when our variable x, the old variable x, is 0, we have to calculate what will be the corresponding value for the new variable. So when x is 0, t will be equal to sine of 0, that is nothing but 0. Right? And when x goes to the highest value, that is when it reaches the upper limit, which is pi by 2, in that case t will be sine of pi by 2, which is 1. So therefore basically our integral after substitution becomes sine cube x becomes t cube, cos x dx is dt, and now the variable of integration is t. So therefore the limits of t are 0 and 1. So therefore we have to replace the limits also. And now the process is simple, that is integral of t cube, as we know, is t raised to 4 by 4, and this is evaluated between the limits 0 to 1. So we can take 1 by 4 common because it's a constant. After putting t as upper limit, that is 1, we will get 1 raised to 4, which is 1, minus t is 0, so 0 raised to 4 is 0. So therefore the answer is nothing but 1 by 4. And this is another interesting thing. Here if you see that there is no t left at the end to resubstitute back into x, simply because the value of definite integral is a pure constant. Right? So that's what we will have to do in every example based on substitution, that we have to change the limits of the definite integral also.